In the grand ledger of the cosmos, survival is not guaranteed by sheer size or age, but by liquidity. A galaxy's ability to remain active depends entirely on its access to fuel. To an astrophysicist, the universe is not just a collection of gravity wells, but a complex financial system where matter flows like capital. The only currency that truly matters in this economy is cold molecular gas, primarily hydrogen condensed into dense, freezing clouds that shield themselves from the ambient radiation of deep space. This gas is the raw material required to mint new stars, the fundamental investments that keep a galaxy vibrant, luminous, and alive. Without a steady supply of this cold fuel, a galaxy cannot build anything new. It stagnates, relying on its existing assets until they inevitably burn out and fade away. When we survey the deep field, we see a population of galaxies thriving in what astronomers call the blue cloud, massive spirals flush with cash. Their spiral arms glow with the brilliant, piercing blue light of massive, short-lived stars, a visible signal that their economy is booming and their gas reserves are deep. These galaxies are the engines of the universe, constantly converting their cold hydrogen reservoirs into nuclear fire, enriching the cosmos with heavy elements. In stark contrast lies the red sequence, a graveyard of cosmic economies where galaxies have ceased all production and settled into a slow, fading retirement. These galaxies appear dull and amber-hued, populated only by aging, low-mass stars that are slowly burning through their fuel with no successors to replace them. The transition from the vibrant blue cloud to the desolate red sequence is the definition of galactic bankruptcy, a state of death by starvation where star formation stops entirely. This is not usually a violent destruction of the galaxy itself, but a financial freeze that turns a thriving metropolis into a ghost town. Crucially, this economy relies strictly on temperature. Gas must be near absolute zero to succumb to gravity, clump together, and ignite fusion. This means that hot, energetic gas is essentially worthless currency. It cannot collapse to form stars, leaving the galaxy rich in matter but impoverished in usable assets. A galaxy's wealth is therefore measured strictly by its reservoir of this cold material, and once that account hits zero, the galaxy is effectively dead. For decades, cosmological simulations predicted that massive galaxies should be overflowing with stars, growing indefinitely as gravity pulls in more gas from the intergalactic medium. These models suggested that as galaxies grow larger, their gravity should only become more efficient at trapping fuel, leading to a universe dominated by blue supergiants. Yet, observational reality contradicts this, showing us a universe filled with red, passive giants that inexplicably stopped growing billions of years ago. There is a missing piece in our understanding of galactic evolution, a force that intervenes to shut down the factory before it reaches peak efficiency. Some mechanism is preventing the universe from being overcrowded with monstrous, overly dense galaxies that defy the laws of structure formation. The data suggests that something powerful is acting as a cosmic regulator, ensuring that growth doesn't spiral out of control, even at the cost of the galaxy's vitality. It is a paradox where the most massive systems are often the first to fail, quenching their star formation long before their smaller counterparts. We now know that the culprit responsible for this recession is not an external invader or a lack of available matter in the void. Instead, it is a regulator sitting at the very center of the wealthiest massive galaxies, a regulator that threatens to empty the bank accounts forever. This regulator is the supermassive black hole anchored in the galactic core, a gravitational titan that dictates the fate of billions of stars. But the true danger to the galactic economy does not arise when this beast is dormant. The crisis begins the moment it wakes up and begins to feed. When significant amounts of matter fall towards the event horizon, the black hole transforms into an active galactic nucleus, or AGN. At this stage, it ceases to be a passive vault of gravity and becomes a radiant engine of thermodynamic destruction, triggering the mechanism of cosmic bankruptcy. Pop culture often depicts black holes merely as cosmic vacuum cleaners that swallow everything in proximity. However, in the context of galactic evolution, their most catastrophic impact comes not from what they consume, but from what they violently expel back into their host environment. This phenomenon is known to astrophysicists as AGN feedback, a process that fundamentally alters the thermodynamics of the galaxy. As the black hole feeds, friction within the accretion disk heats the infalling matter to billions of degrees, generating twisted magnetic fields that launch colossal jets of plasma. These jets and distinct high-velocity winds slam into the surrounding interstellar medium with the force of a million supernovae. The black hole is effectively converting gravitational potential energy into kinetic energy, transferring it directly into the galaxy's savings account, its vast reservoirs of cold molecular gas. To understand why this is fatal, we must look at the physics of star formation, which is the galaxy's only method of generating wealth. To mint a new star, molecular gas must be incredibly cold, often hovering just a few degrees above absolute zero. Cold gas possesses low internal pressure, allowing gravity to overcome thermal motion and pull the clouds together until they collapse into stellar cores. But the shock waves from the AGN inject massive amounts of thermal energy into these clouds, acting like a cosmic blowtorch. This injection of heat causes the gas particles to move frantically, drastically increasing the internal pressure of the clouds. The delicate balance is shattered. Gravity can no longer overcome the thermal turbulence, and the gas refuses to collapse into new stars. The galaxy effectively still possesses the raw material, but it has been rendered chemically and physically useless. These are frozen assets in the truest sense, fuel that is present but inaccessible, locking the galaxy into a recession from which it cannot recover by internal means alone. Yet, the devastation wrought by the active galactic nucleus does not stop at merely heating the reserves. If the feedback is powerful enough, the radiation pressure and particle winds begin to physically evict the gas from the galaxy entirely. We observe massive molecular outflows where the galaxy's fuel is accelerated to velocities exceeding millions of kilometers per hour. The black hole is literally blowing the galaxy's atmosphere into the intergalactic void, pushing the precious cold gas beyond the reach of the galaxy's gravitational pull. This sterilization process extends even to the invisible halo of gas that surrounds the galaxy, which serves as its long-term fuel tank. The AGN heats this halo, creating a high-pressure thermal barrier that acts like an impermeable force field against the outside universe. Under normal conditions, fresh gas from the intergalactic medium would rain down to replenish the galaxy's supply. But the heated halo blocks this accretion, effectively preventing any external financial aid or resource injection from reaching the starving disk. The galaxy is now besieged from the inside out, cut off from new resources while its existing reserves are exiled. It enters a terminal phase known as quenching, creating the red and dead galaxies that populate the cosmos. For decades, this was a theoretical model until the James Webb Space Telescope finally caught a galaxy in the act. The evidence comes from a specific target that astronomers have recently analyzed in unprecedented detail, a massive structure formerly cataloged as GS10578, but colloquially known as Pablo's Galaxy. Located 11.5 billion light-years away, this object offers us a pristine, undisturbed window into the universe as it existed just 2 billion years after the Big Bang. By all conventional models of cosmic evolution, a galaxy of this immense size in the early universe should be a chaotic factory of creation, rapidly minting new solar systems to build its mass. But when the James Webb Space Telescope and the Atacama Large Millimeter Array focused their combined sensors on this coordinate, they found something deeply disturbing. GS10578 is effectively dead. Its star-forming engines have been completely silenced, leaving it drifting as a massive passive relic in an era that should be teeming with radiant blue light. The urgent question for astrophysicists was never whether it was dead, but rather who or what had killed it with such absolute efficiency. The forensic analysis of the light spectrum revealed the culprit immediately: a supermassive black hole sitting in the galactic core, still glowing with the thermal signature of a recent feast. This was not a dormant gravity well, but an active engine that had been running at maximum capacity during the galaxy's formative years. What makes this discovery historic is not just the presence of the black hole, but the visible trail of evidence it left behind in the surrounding medium. The instruments detected massive plumes of material being driven outward from the center, riding on high-velocity winds generated by the accretion disk's intense magnetic fury. Spectroscopic analysis identified this ejected material specifically as cold molecular gas, the exact financial currency required to build stars. The black hole was caught in the act of physically stripping the galaxy of its liquidity, forcing it into a permanent recession by expelling the very fuel it needed to survive. The scale of this eviction is difficult to comprehend, with the dense gas clouds being accelerated to speeds exceeding 3.5 million kilometers per hour. At this extreme velocity, the material effectively escapes the galaxy's gravitational pull, lost forever to the intergalactic void, where it can never collapse to form a star. This confirms the death by starvation model, where the central engine does not need to destroy the stars that already exist, but simply ensures that no successors can ever be born. It is a slow, suffocating process that transforms a vibrant blue spiral into a stagnant, red and dead elliptical. This specific observation provides critical support for the M-sigma relation, a tight correlation observed in the local universe between the mass of a black hole and the velocity dispersion of its host galaxy. GS10578 proves that this gravitational tyranny is established very early in cosmic history, locking galaxies onto a set trajectory. Furthermore, the energy pouring out of the core heats the surrounding galactic halo, creating a thermal shield that prevents fresh gas from falling in. The black hole essentially imposes a blockade, ensuring that even if the galaxy wanted to recover, it cannot import new fuel from the outside to restart its engines. While this destruction seems catastrophic, cosmologists now understand it as a necessary form of regulation for the structure of the universe. Without these violent feedback loops, simulations suggest the modern cosmos would be populated by monstrous, overly dense galaxies that defy the laws of structural stability we observe today. The black hole acts as a strict cosmic governor, curbing the reckless growth of its host to ensure the galaxy remains within sustainable limits. It is a violent paradox where the destruction of potential life is required to maintain the structural order of the cosmos on the grandest scales. We now have the observational proof that the silence of the night sky is often enforced by the screaming jets of active galactic nuclei. GS10578 stands as a monument to this process, a galactic corpse that has finally taught us exactly how the universe balances its books. As we continue to peer deeper into the infrared with JWST, we will likely find more of these cosmic crime scenes, revealing the true cost of galactic evolution. If you enjoyed this investigation into cosmic economics, make sure to like and subscribe to QuasarQuest for more deep space astrophysics.